and just review some basics. When graphing, oh, that's a lovely axis there. When graphing exponentials, we always know that a 0 power and a first power will generate certain answers. So let's say we have y equals a to the x as an example. We're always going to have 0, 1 on our graph, and whatever our base happens to be, we're always going to have that value as a second point. A reminder too that any time we graph an exponential, we should include the asymptote and a complete graph with arrows at the end. One mistake I had seen on the formatives is some of us were simply graphing. Let's see if I can get a different color for us here. Some of us were simply graphing something like this and stopping here, because I think that's where the calculator stopped giving you a piece of the graph because of the pixelization, etc. So do not please rely on that as your help and aid, especially in this part 2. We have no calculator. So let's see if I can get rid of some of this stuff here. Let's just add a new slide. Secondly, as we're graphing logarithmic equations, and again, those are very much related. Logarithmic graphs are the flip. So in logarithmic graphs, we'll always have this general shape. There is this time a vertical asymptote. And you might recall that these logarithmic graphs were inverses of exponentials. In other words, they are mirror images of the exponential graphs reflected in the line y equals x. So just that as a sample as we... And now on to the actual review itself. So as we look at what we have here, graph the following functions, state, domain, and range. So number 1 and number 2 are both exponential in style, and we have changes happening in certain places. First of all, the domain. For all exponentials, the domain is, of course, all real numbers. And the range is going to be affected by the asymptote. Since the base here is 3, we know this is a growth. And scooting ahead to number 2, since the base is 1/2, we know this will be decay, because everything is being multiplied by half of its value. So let's have a look at this graph. A quick little t-table will get us to a couple of points we can use, x and y. Choose 0, 1, -1, just to get a value. 3 to the 0 is 1 times 2 is 2. 3 to the first is 3 times 2 is 6. 3 to the negative first is 1/3. So that would be a value of 2/3. So to get us some values here, again, the size of the graph will limit what we can do. 0 across and 2 up puts us about here. 1 across, 0 across. That's good grams. 0 across and 2 up puts us here. So this graph is in effect stretched vertically. 1 across and 6 up. 2, 4, 6 will put us about here. And -1 2/3 gets us about here. Again, tough to draw this graph. Since there is no upshift, we know that our asymptote is at y equals 0. And then to actually sketch the graph, try to bring it through here as best we can on this technology. Always tough drawing with the stylus on the screen. Arrows at the end, of course, to finish things off. Okay, not the best. Range there, then, of course, we want to re-enter that up top as all real numbers such that y is greater than 0. again, we cannot reach a y value of 0 for these graphs. Number 2, just to review what's happening there, we have there a number of different values. We already talked about the base here, making this a decay graph. The +5 and the +4, +5 again would be a vertical shift, and the +4 would be a backwards shift 4. So before I start that process, I'm going to look at the graph that we have, and I'm going to consider this -3. Certain things happen when we have that number out front. First of all, this will be a stretch, like the 2 did in the first graph over here. Also, the negative will flip this upside down, so there are multiple changes happening. The normal graph of the f of x equals 1/2 to the x would be a decay graph, and it would look something like this. So our starting graph would look something like this. Asymptote. So as I would stretch that graph, first of all, a stretch would do something like this. Make it a bit thinner. Again, does not change our asymptote there at all. And then the negative would flip that upside down. So if I visualize that, I would be doing something like this down below. That takes care of the negative and the 3. So the blue is done. And then for the yellow graph, we'd be shifting this entire graph 5 up and 4 back. So every point, and we're going to locate some key points, this one here, and the value of 1 we will figure out too, where the x has a value of 0 and the x here has a value of -1, and possibly find a value of 1 as well, and take each of those points, shift them up and back, up and back, up and back, and then we'll get a decent look for this graph. So back to our starting point after those generalities. Let's find a color I like here. So let's first of all set up a short little t-table, and first of all graph -3, 1/2 to the x. So again, -1, 0, and 1. Plugging in -1 for the power, 1/2 to the -1 power would be 2, times the -3 would be -6. 1/2 to the 0 power would be 1, times the -3 is -3. And then 1/2, of course, to the first power is 1/2. This would be -3/2. So this would give us some values, 0 across 3 down, something to nail down on our graph as our first set of changes. 0 across 3 down, 1 across 6 down, and 1 ahead, and -3/2. So we're looking at about right here. So our starting curve would look something like this. And now we have to do the shifting, which I've indicated in yellow, up and over. So the xy pairs would change accordingly. So the x would be -5, shifting backward 4, and the y value, I'd add 5 to the values I have. I'll do that real quickly here. If I add 5, I get +2. If I add 5 to -1.5, I should get 3.5. And let's see, adding 4, or subtracting 4 rather. So now I can plot these yellow points, and from there do the best I can with a curve. So -5, -1 puts me here. -4 and 2 puts me here. And -3, 3.5 puts me about here. Another point to notice, the asymptote, horizontal asymptote, has shifted up to 5. 1, 2, 3, 4, 5. So my horizontal asymptote will be penciled in here. And then to draw a smooth curve to the best of my ability through. So the yellow curve would be my finished curve here. Should thicken up my cancel a little bit here. And it should also indicate y equals 5 is my asymptote. So visually from the graph, we can see for domain, it's again all reals. And then for the range, we can see visually from the graph that we have all reals such that y is less than 5. So that'll complete the first two graphs.